I push a box across a smooth floor at a constant speed by applying a force of 175 newtons at an angle of 25 degrees relative to horizontal. If I displace the box a total of 225 centimeters, what total work did I do? So the scenario I'm imagining here in this example is like, let's say I've got a box like this, and we're going to slide it on a floor here. So I'm not, whoops, try to put in a floor here. Maybe it's floating in the floor there a little bit. But anyways, we're just going to slide it across this floor. But instead of applying a force that is perfectly horizontal, it says at an angle of 25 degrees relative to horizontal. I'm actually meant that to be a downward kind of oriented force because I think that makes sense for how a person would probably push a box. And when I say it's 25 degrees from horizontal, I think that means that this angle here is 25 degrees. Well, maybe I could also done an angle right here. But anyway, that's the applied force F. And it is displacing horizontally a distance d. And here I'm going to say F is equal to 175 newtons. D is equal to 225 centimeters based on the numbers given to me. But clearly force and displacement are not in alignment perfectly. So the work formula I'd like to use in this scenario, instead of the simplest case, would be the just simple case of FD cosine theta. And based on maybe the identification up here that 25 degrees is equal to the angle theta. Well, actually, is that correct? Maybe I should be a little bit careful here, right? Because like really that theta should be the angle between the displacement vector d. So I've redrawn that there. And if I take the force vector and I redraw it so that they're both kind of got their tails in the same spot, so there's the force vector F. This really should be the angle theta that goes into this formula. But I think we'd all agree that when I move this force down here, this theta really is that same angle that it makes with a direction that's horizontal because, well, D point's horizontal. I think that's obvious enough from that picture. That means I'm going to do 175 newtons. The one thing I might like to think about a little bit here is units. Maybe base units are my friend here. So instead of 225, I'm going to multiply by 2.25 in meters. And that's because we've seen before that the Newton times a meter is going to be a joule. And so if I'd like to report my answer in joules, which is usually a good idea, I mean, you could ask, like, is that a requirement? And you know, it depends. If the question doesn't say, maybe you could do like, okay, I'm going to give my answer in Newton centimeters, but don't call that a joule because it's not one. If the question says answer in joules, you obviously should do that, and it's generally probably best practice to do that. Anyways, so having put that into the SI base units there, or derived units in the case of the Newton, but then I'm going to put into my calculator 175 times 2.25 times the cosine of 25 degrees. And my calculator says 356.8586911. But let me see. I think maybe 3 significant figures is probably going to be okay here. 357. And again, Newton times meter, but I can safely turn that into a joule. One could argue maybe maybe I should have done 2 sig figs, but I often with angles don't apply those same rules because it's inside a trig function. So there it is, 357 joules.